In the summer of 1877, millions of people starved to death across British India's Madras Presidency. The streets and villages were filled with bodies. The starvation reached far across the globe. Millions more died in China, and nearly 2 million perished in Brazil. People on entirely different continents were collapsing from hunger at exactly the same time. This global devastation traced back to a specific patch of water thousands of kilometers away, off the coast of Peru. Local fishermen had noticed a section of the ocean becoming unusually warm, eventually naming the phenomenon El Niño. That year became known as a super El Niño because the extreme ocean warming triggered a deadly cascade in global weather. Now, almost 140 years later, major European forecasting models are flashing red. They predict an extreme El Niño is returning in 2026. Historically, a severe El Niño temporarily spikes global temperatures. Before the Industrial Revolution, when one of these extreme events occurred, the planet would heat up by roughly 1.4 to 1.5 degrees Celsius on its own. Today, we are starting from a completely different foundation. Because of human-caused climate change, our planet's baseline temperature is already sitting right around 1.4 degrees above the pre-industrial average. Imagine sitting in a room that's already 40 degrees Celsius, and someone turns on a heavy-duty space heater. You take our elevated 1.4 degree baseline, and you add the 1.5 degree El Niño spike on top of it. That equals a net temperature anomaly of 2.9 degrees Celsius, a level of sudden, compounding heat never before experienced in human history. To understand how this works, look at the Pacific Ocean. Normally, trade winds blow from east to west, pushing warm surface water toward Asia and allowing cold, nutrient-rich water to rise up from the deep near South America. But during an El Niño, these trade winds weaken. The cold water stops rising. Without that cold water to regulate the surface, trillions of liters of ocean water consistently heat up. This massive thermal pool releases so much energy into the atmosphere that it rewires planetary wind currents, pulling rain clouds away from Asia and dumping them into the middle of the ocean. This chart shows sea surface temperature data during a severe event. The deep red anomalies stretching across the equatorial Pacific map out areas where the water has spiked wildly above normal, showing the raw scale of the heat engine. For India, the timing of this oceanic shift is disastrous. The upcoming 2026 event is projected to peak right between May and July. That is the exact window when the country needs its monsoon rains the most. The lack of rain creates an immediate crisis for the food supply. Roughly 51% of India's agriculture relies entirely on those specific monsoon downpours to survive. When the rains fail, the crops wither. When crop yields drop, the cost of groceries spikes. During a standard El Niño, global food prices often rise by 5%. Under the strain of a super event, crop failures trigger massive shortages, pushing food inflation up to 9% and draining household budgets. While a 2.9 degree global average sounds abstract, the local reality is blistering. In 2024, cities like Delhi and towns in Rajasthan already recorded daytime temperatures cracking 50 degrees Celsius. Cities act as forced multipliers for this heat. When developers remove trees and replace open spaces with dense concrete, they create an urban heat island. The concrete absorbs the sun's radiation all day long and then slowly releases that heat throughout the night. The city literally never cools down. To survive this, people who can afford it blast their air conditioning. But AC units do not eliminate heat, they simply move it. They pump cold air inside while venting intense exhaust heat directly into the streets, baking the surrounding neighborhoods even further. The true physical burden falls on the 38 crore, or 380 million, workers in India's informal sectors. Delivery drivers, street vendors, and construction workers are forced to absorb this multiplied heat out in the sun, with no access to AC, no paid leave, and no health insurance. This heat directly erases their livelihoods. Studies show a single-degree rise in temperature can drop an outdoor worker's daily earnings by 14%, as their productivity plummets and their out-of-pocket expenses for medicine, water, and ice go up. Officially, India recognizes 12 types of natural disasters, a list that includes cold waves but notably excludes heat waves. Because heat deaths are often recorded as cardiac arrest or organ failure rather than environmental exposure, the official count remains artificially low. This technicality keeps the National Disaster Fund closed. Notifying heat waves would legally mandate the government to pay 4 lakh rupees in compensation for every confirmed death, a cost officials stated in Parliament they have no plans to incur. Surviving the 2026 Super El Niño will have very little to do with biology. It will be a brutal test of socioeconomic class, a matter of who can afford to buy their way into a cooled environment and who is abandoned to the concrete. While global ocean temperatures are far beyond individual or even national authority, local heat multipliers are a direct product of city planning. The way we design our streets, preserve our canopies, and choose our materials determines whether an urban neighborhood becomes a sanctuary or a furnace. The most effective cooling technology is remarkably simple: a mature tree canopy. Extensive data shows that planting tall, shade-providing trees can drop pedestrian-level temperatures by a massive 12 degrees Celsius. Yet the current strategy across Indian cities is the exact opposite. Century-old trees and dense urban forests are being actively bulldozed to make way for new concrete highways and massive development projects, erasing the exact natural defenses we desperately need. The immediate defense strategy has to be local. Citizens must fight to protect old-growth trees in their neighborhoods. Keep low-cost hydration packets like ORS on hand for outdoor workers. And we have to start moving our homes off a coal-heavy electrical grid by adopting independent solar power. Transitioning to solar is highly accessible now. It has become so cost-effective that people living in war-torn regions like Syria are using basic, street-level solar panels to keep their lights on and their families alive. The Super El Niño arriving in 2026 will eventually pass, but it will return a few years later, striking an even hotter global baseline. For a child born today, the 35-degree summers we remember from our childhoods simply do not exist anymore. 45 degrees is their new normal. We have to adapt our cities to survive it right now.